So following on from that previous example, what we're going to do now is we're going to have a look at this next example. We've got sequence 2, 6, 12, 20, and then 30. So once again, I need to check whether or not this is a linear sequence by checking the first differences. So what I end up getting is that this is the difference of plus 4, difference is plus 6, plus 8, and then plus 10. So my sequence is definitely not linear because the first difference is not constant. So then I have to find the second difference. So my second difference is plus 2, and then plus 2. From here, what I need to do is then take the form that I looked at before. A n squared plus bn plus c. So the first thing I want to work out is this a bit. The way I work out this a bit is by checking this 2. So all I need to do is take the difference, take the half of second difference to find the value of a. So that means half of 2 is 1. So that means a is equal to 1 in this case. Or in other words, I have 1n squared or just n squared. So I'm going to put this n squared right there. Next thing I do is calculate my n squared sequence. My n squared sequence will be 1, 4, 9, 16, and then 25. From here, what I'm going to do is I'm going to then find the sequence, take away the row above. The proper term for this is actually called the residue, and it's not necessarily it's just the term that I'll be using when I'm referring to sequence minus the above row. So from here, I do the sequence, take away above row. So 2 take away 1 will give me 1. 6 take away 4 will give me 2. 12 take away 9 will give me 3, and the next one will be 4, next one will be 5. So now I'm actually in the process of calculating these last 2 bits. So I'm in the process of calculating the B and the C. So now I need to find the first difference of the residue. And so this ends up becoming plus 1. And this one's plus 1. And this one is plus 1. Plus 1. Which is great because now this has a constant difference. Or in other words, if we look at the value of B, the value of B is 1, or in other words, 1n. So I'm going to put the 1n here. Now, let's have a look at the 1n sequence. So 1 times 1 will give me 1. 2 times 1 will give me 2. 3 times 1, 3, 4, 5. Now, I need to have a look at the difference between that particular number, the residue, and here. What's the difference? 0. What's the difference here? 0. Difference, 0. 0, 0. So now, I've got, from my original sequence of an squared plus bn plus c, I have this first bit, which is going to be n squared, this next bit, which is positive or plus 1n, and the next bit, which is plus 0. Or if we simplify that, that is the same as saying n squared plus n. Now, are we sure that this is the right function? Check. Or right sequence. Sorry, I didn't mean to say function. Check n equals 2. And so we substitute 2 squared plus 2. 2 squared is 4 plus 2, or in other words, that's 6. Now, will 6 give us that first thing? And yes, 6 is the correct answer in this case. So that means I'm not going to double check, but yes, that is the right sequence, n squared plus n. Now, let's look at one more example. So, obviously I'd like you to pause this video before I do go through it and see if you can actually work out the sequence. or the rule for this. Okay, now that you've had a shot of this, let's go through it. So the first difference. This is a difference of 11. This one's a difference of 15. This one's a difference of 19. This one's a difference of 23. Now it's not linear because the first difference is not constant. Now let's find the second difference. 4, 4 plus 4. Now here's where here's where it gets interesting. So if we take that, I keep doing a squared. A n squared plus bn plus c. So if we take that original general form that we talked about, we said take this number 4, half 4, so half of second difference is what we wanted. So what's half of 4? That's 2. So in other words, our a value is 2. Or in other words, our thing is going to be 2n squared. So I'm going to chuck 2n squared right here. 2n squared. Now I'm actually going to come up with a different sequence now, because since I've got 2n squared here, this will be 2. 2 squared is 4, times it by 2 is 8. 3 squared is 9, times it by 2, 18. 4 is 16 times 2, 32. And 5 squared is 25 times 2, which is 50. Next step, I'm actually going to find the residue now. So what is the difference between these two numbers plus 2? The difference between these two numbers is plus 7. The difference between these two numbers is plus 12. Next one is going to be plus 17, and the next one's going to be plus 21. So now I've got the first part of my sequence sorted out. I just need to find the next few parts of my sequence. So the next one, first difference of these two. First difference, first difference, first difference. So this is 5 plus 5 plus 5 plus 5. I think I made a small mistake here, guys. I'm just going to change this to 22 because the difference between 50 and 72 is 22, not 21. I do apologize for that. So now my B part is going to be 5n. So 5n will go there. So let's come up with my 5n sequence. This will be 5, 10, 15, 20, 25. From here, I just need to work out what is the difference between this number right here and this number. So the difference between 2 and 5 is minus 3. The difference between 7 and 10 is minus 3. The difference between 12 and 15 is minus 3, minus 3, minus 3. So now I've got my 3 parts that I need. And I'm going to write it out as 2n squared, which I got from here, plus 5n minus 3, which I got from the differences. So then we're going to check n equals 2. So then we get 2 squared plus 5 times 2 minus 3. So this will become 2 squared is 4 times 2, 8 plus 10 minus 3. This will become 15. So let's see if 15 is right. And 15 is correct, which means that this sequence, I'm not going to double check once again, but that sequence should be right. So what I'm going to do is I'm going to pause this video right here, and I would like you to come up with this sequence, and I'll continue the answer for this in the next video. So 7, 16, 31, 52, and 79.